Math 1314, section IC1, spring 2022, Tyler Junior College, section 5.1, distance and midpoint, video 2, midpoint formula. As this title implies, now we're going to find the formula to find the midpoint between 2 points. Now, what exactly do we mean by that? Well, let's go into Desmos and take a look at the same 2 points that we found the distance between in the previous video. Those points would be 4, -1 and 10, -9. What do you think I mean by midpoint between those? Well, it's a point in the middle, specifically midway between the two. So for example, if I were to just drag this point from the beginning, from 4, 1, all the way to the end, 10, 9, where's the middle? About here, maybe right there at 7, 5. Well, let's plot that point and think about whether or not it makes sense for it to be the middle. I mean, how could we measure if it's in the middle? Well, if you're thinking in terms of distances, that's not a bad thing. We had calculated the distance between the 2 points on the ends earlier. The distance from 4, 1 to 10, 9 was 10. So if the midpoint is truly in the midpoint, how far would it be from either end? Well, if the distance all the way across is 10 and the midpoint is in the middle, then it would stand to reason that the distance between either end and what we're claiming is the midpoint would be half of 10, which of course is 5. Could we find the distance between these? Yes. Could we find the distance between, let me say that again. Could we find the distance between the first point, 4, 1, and what we claim is the midpoint, 7, 5? Yes. Would its distance be 5? Actually, it would be. And if we found the distance between the midpoint, or what we claim is the midpoint, 7, 5, and the other end of the segment, 10, 9, would that distance be 5? And the answer again would be yes. It actually is the midpoint, but we need to find a more reliable way to locate the midpoint besides just saying, I think that works. And although the midpoint is the point on the segment that is half the distance across, or equivalently the same distance from one end to another, even if I knew that distance, how would I locate that point? Like if I didn't tell you where the midpoint was, but we knew the distance between the 2 points was 10, and therefore the midpoint had to be halfway across at 5. How could you travel 5 in that direction and know exactly where to stop, since we're going neither horizontally nor vertically? There's a calculus way to do it, but needless to say, this is in calculus. So we need to find a better way to locate the midpoint besides saying, I think this point works, and then checking it after the fact. In order to do that, we're going to use the same trick that we did when we discovered the distance formula, and that's we're going to look at things from the X perspective and from the Y perspective. Let's go back to the whiteboard and I'll show you what I mean. In this picture, I have the segment connecting the points 4, 1 and 10, 9. I do want to draw my 9 a little bit better. And I've got a generic point label in the middle with XM, YM, the subscript of M, of course, meaning midpoint. And we want to see if we can deduce what the coordinates of the midpoint have to be according to the coordinates of the endpoints. Let's start by projecting this picture down to the x-axis. In other words, let's just look at all 3 points of concerns. All 3 points of concern, let's look at all their x-coordinates. The leftmost point's x-coordinate being 4, the rightmost point's x-coordinate being 10, and the midpoint's x-coordinate being somewhere in the middle, being XM. Now, could we have the distance argument down here? Actually, we could. It's much easier to have the distance argument in 1 dimension than 2 dimensions, because in 1 dimension, distance just means subtraction. So if we were to look at this picture down here, then the distance between 4 and XM would just be XM minus 4. That's how far apart they are, greater minus the lesser. But that should equal the distance from XM to 10, and that distance would be 10 minus XM. Well, we end up having a linear equation in 1 variable, just XM. So we can solve this like we did before. We could add XM to both sides because we have them on both sides and we don't want that. that would cancel the xm's on the left and leave 2xm on the, cancel the xm's on the right, leave 2xm's on the right. We still have the -4, and we still have equals 10. And now we can just add 4 to both sides to get 2 times xm is equal to 14. And at this point, I think it's fairly clear that if we divided both sides by 2, we would get that xm is equal to 7. In other words, the x-coordinate of the midpoint indeed was 7. Now we could replicate the same thing on the y-axis. We could take the y-coordinate of the first point, which is 1, the y-coordinate of the second point, which is 9, the generic y-coordinate of the midpoint, which is ym, and also set up the same equivalencies that the distance from 1 to ym, which is ym minus 1, would equal the distance from ym to 9, which would be 9 minus ym. So if we put these equal to each other and did the same thing, we would find out that ym is equal to 5. So 7.5 is the correct answer because it's the x in the middle of the x's and the y's in the middle of the y's. So can we turn this into a formula? Well, we do that the same way we did it before with the distance formula. We set up a generic problem and then try to replicate the process. And at the end, we would get a formula that tells us exactly where the midpoint is. Now, your intuition might be screaming, I know how to find the midpoint. Don't build a formula. That's great. Then I want you to write down what you think the formula is. In other words, instead of trying to find the midpoint between 4,1 and 10,9, how would you find the midpoint between x1, y1 and x2, y2? In other words, 2 generic points. Well, let's see if we can play the same game we did before. That game was to put, some generic points. There's some ordered pairs here. We'll call the first ordered pair x1, y1, and the second one x2, y2. Label the midpoint something generic, like xm, ym, and see if we can play the same game that we did before, like back here on the x-axis when we put the xm between the 4 and the 10. In case you're not sure where I'm talking about right here. And then from that, we said, well, the distance between xm and 4 has to be the same as the distance between 10 and xm. Solve that equation for xm. And if we do that generically, we'll have our formula. So let's do that generically. On the x-axis, our first x is x1, our last x is x2, and the midpoint's x is xm. Now you're going to have to keep track with some variables here. But it's algebra, so surprise, surprise. The distance between these two is the greater minus the lesser. And based on the way the picture is drawn, xm is greater than x1. So we have xm minus x1 is that distance. But then we need to say it's equal to the distance between xm and x2. And since x2 looks to be the greater of the two, we would do x2 minus xm. It's supposed to be green. Minus xm as the distance between the middle x and the second x. Keeping in mind that we're trying to find a formula that tells us how to calculate xm. We want this to say xm equals, so we have to solve for xm. When we did it back here, we started by adding xm to both sides to get rid of it on the right. Sounds like a perfectly good move over here. Add xm to both sides. That will cancel the xm's on the right. That'll give us 2 xm's on the left. We still have minus x1 and then equals x2. And now that we have a single xm, we can just start solving it by getting rid of everything attached to it, starting with adding x1 to both sides. That cancels the x1s on the left and leaves us 2xm equals. Now on the right, we have an addition problem that we can't complete because these numbers are generic. We don't know what they equal. We're trying to add x1 and x2. So the best we can do is write x1 plus x2. You could also write x2 plus x1, but given the option, I prefer my subscripts in order. And then the only thing that's keeping the xm from being by itself is the times 2, and we know how to get rid of a times 2. We would divide both sides by 2. And that would give us xm equals, well, it doesn't fit in the space that I've left, so I'll go over here and write it on the next page. That gives us that the x coordinate of the midpoint is the first x coordinate plus the second x coordinate, and that's sum divided by 2. Now, we could play the exact same game with the y's, but what would happen is everything that's happening over here in this box, that I wanted that to be blue, everything that's happening over here in this box would happen again. The only difference is every x would be a y, which means the results would be the same, except every x would be a y. So for the y midpoints, for the coordinate, try that again. For the y coordinate of the midpoint, you would add the first y plus the second y divided by 2. Now, we can box these together as 2 individual formulas, or we could just write the following: an ordered pair formula. The x coordinate of the ordered pair is x1 plus x2, the sum divided by 2. And the y coordinate is y1 plus y2 divided by 2. And that is the formula that you will see in most books for the midpoint of 2 points, 2 generic points, x1 comma y1, x2 comma y2. Now, before we do an example, because these are really easy, I do want to point out something really convenient about this formula, and it's not really an accident. But all you're doing is averaging. If you took a class that only had 2 grades all semester, a midterm and a final, and each one counted the same weight, how would you find your average at the end? How do you average 2 numbers? You add them and divide by 2. That's all that's happening here. So an easy way to think about the midpoint is the following. If I can get the text box to draw. Midpoint equals average of x's, comma, average of y's. I'm going to format this a little bit better here in just a second by widening the text box. There we go. So you can just remember that the midpoint is like the average of 2 points. And so to find the midpoint's coordinates, you just average the x's and average the y's. Let's take a look at a real quick example because these don't require a lot of work. Okay, we'll do 2 quick examples. Find the midpoint between the given points. A, the point 5, comma 3, and the point 11, comma -5. I invite you to pause the video and try both of these because they're both really easy. The second one has a couple of small points that I want to make, but it doesn't mean that they're difficult. They're pretty easy. Last chance to pause the video. All right. To find the midpoint, you average the x's and average the y's. The x coordinates in part A are 5 and 11, so we'll average those by adding them and dividing by 2. And the y coordinates in part A are 3 and -5, so we'll add those and divide by 2. Now, how quickly it takes you depends upon how good your math skills are. I'm going to take these step by step, but they're not that difficult. In the first fraction, 5 plus 11 is 16. That currently lives over 2. And in the second fraction, 3 plus -5 is -2, which also lives over 2. And both of these being even can be divided by 2. Our midpoint is a, comma -1. Part B is no more difficult, but it does have a couple of things worth mentioning. Again, if you want to try it and haven't, you better pause it because here I go. I'm going to go ahead and set up the add and divide by 2 scheme on both of them. It's never a bad idea in a formula to set up everything except the numbers you're going to substitute and then carefully substitute them in. In fact, I probably should have gone back here and said first x, first y, second x, second y, and then labeled where I was going to put all my values here, x1 plus x2 on the top there, y1 plus y2 on the top there. If we did that over here, x1 is 3, y1 is 7, x2 is 4, y1 is -7. In the first fraction, we add x1 and x2. Well, x1 is 3 and x2 is 4. In the second fraction, we add y1 and y2. We add the y's. Our y's are 7 and -7. In the first fraction, 3 plus 4 is 7. That's over 2. In the second fraction, 7 plus -7 is 0. That's also over 2. So my 2 comments are this. Number 1, sometimes your fraction won't divide evenly, like we have 7 over 2. Now, we can turn it into 3.5. Or we can just leave it as 7/2. Don't write it as 3.5. Never give a mixed number answer unless you're measuring something. Mixed numbers are horrible for doing math with. Great for measuring, horrible for math. So either leave it as 7/2, or if the homework requests a decimal, call it 7.2. But I would just leave it as 7/2. And the other issue is if you get 0, that's okay. 0 divided by 2 is 0. And there's our midpoint. So midpoint's pretty easy concept. Are there more difficult variations of the question? Depending upon the types of numbers you use for your coordinates. But at this level, we're not going to go down that path.